Hi, good evening, Mr. Shatish.
Yeah, yeah, good evening.
We'll wait for 5 minutes. Let
Yeah,
some, if some other people can join, then we'll
yes.
start the session.
Yeah.
Good evening, sir.
Good evening. Like I can see some familiar faces and some are joining first time. So if you guys can introduce yourself, it would be better. Like in a very brief.
Last time introduced myself.
Hmm.
I am retired commissioner cum secretary and chief engineer from Port Blair, basically from Central PWD. 35 years service. After that, I became director of some engineering college,
Hmm.
and now I'm a consulting engineer in the area of geotech here
Nice.
at Indore.
Thank you, Mr. Shatish.
Yeah.
Anyone else? Okay. Mr. Nilgriv, can you introduce yourself?
Sure, sir.
It's not working.
Good evening, sir. Good evening, everyone. I am Nilgiri Pavanti. Uh, After completing my BTech from Odisha Engineering College, Bhubaneswar, in the year 2012, I did my MTech from ITR in Geotechnical Engineering. Right now, I am continuing as a guest faculty in the Department of Civil Engineering in College of Engineering, Keonjhar. Thank you.
You can hear me, right? Okay. Mr. Sujin Sunil, can you introduce yourself? Okay. Uh, Taso Sia. Sorry if I'm pronouncing name wrong. Okay. Can you introduce yourself once? You can write in chat box also if you want. Okay, okay. Uh, wait. I can't hear. Guys.
Audio is not there.
Yeah, now I can hear. Okay. Sorry, I can't hear. You can write in chat box if your audio is not proper. Okay. And meanwhile, if Gitu MR, if you can introduce yourself. Okay. Good evening, Srinath. Okay, it's 6:05, so we'll start the discussion. First, let me share my screen first. Wait. What happened? Shoot. Okay, welcome Taso and welcome Gitu. Wait, it's not working. Okay, I guess you can see my screen.
Yes, please. Yes.
Okay,
Yes, sir.
okay. Okay, good evening everyone. I'm Balram Shah. I'm a PMRF TA for this course called Subsurface Exploration Importance and Techniques Involved. So I am a PhD scholar at Interdisciplinary Center for Water Research at ISC Bangalore. So I will be discussing today about the week 2 lectures, and if you have any doubts about the week 2 lectures, and I will be helping you with some type of assignment questions, not the exact assignment questions that you are going to do for the week 2 lectures, but I have made some assignment questions for you to understand what is going on. So as I said, it will be better that if you before this discussion session you go through all the video lectures by a professor. So we'll start the session now. Okay. Before that, anyone is having any doubts in week 1 lectures or any issue in the week 1 assignments?
Um, Sir,
Yes, yes.
actually, I have missed the class of assignment class of week one lecture.
Okay.
So, sir, is there any possibility that we can get that particular recording, or by any means
Yes, it's like
I can access?
yeah, I got your point. I have recorded the
Uh,
lecture and I have given it to the PMRF team, the NPTEL team. I guess they should have been, if they have not given the sheet till now, because in that I have given the YouTube links and all the PDFs and all PowerPoint, whatever I have shown in the discussion session. I have
okay.
given everything to the NPTEL team. If they have not
Uh,
responded and if they have not sent to the all the students, I will let them know. They will be giving it by maybe today or tomorrow. Okay, you'll get all that.
oh,
All the discussion session I will be recording, and you'll get all this. It's already okay. So,
okay.
so it's I think it's uploaded. Okay, if you see what Mr. Shinad has said, it's already uploaded below week 3 lectures. So you can go there. You will find everything. You will
Yes,
find
sir.
the recording for the YouTube lectures. You will find the PPT that I have showed, presented, and the PDF also in which I have explained some of the topics. Okay.
Thank you, sir. Thank you so much.
Okay. Anything other than that? Okay. So if there is nothing based on the week 1 lectures, we'll start the session for the week 2 lectures. Anyone have done the assignments for the week 2 lectures, or any doubts related to week 2 lectures?
Uh, Mr. Balram, I have done
Okay. Any
uh,
any doubts you have?
this this probability to
Sorry,
question
your
9
voice is breaking.
as
I
per
can't
our
hear.
calculation.
Can you please?
Uh,
Okay, okay. Now I can hear
uh,
you.
this question 9,
Okay.
whatever answer I am getting,
Hmm.
that is not telling with any one of the answers given.
Okay, okay. That I will check.
That is the problem.
Okay. For
I
the
have checked and rechecked.
okay, for
Question number
the
9.
current assignments, I can't help. I can only give hints.
Yeah, yeah,
So I will
yeah.
check that. I'll let you know. Okay. 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 So we'll start the session for the week 2 lectures. It's recording, right? Yeah, it's recording. Okay. You can see my screen, right? It's visible. Okay. So in this week 2 lectures, what all we have seen in the lectures are we gone through the trial pits, the method of investigations, then like what are the methods on the site, or what we can do manually and all. Okay. Before that, what we have gone through, why we are doing subsurface exploration, what is the need of doing subsurface exploration, what are the investigations that are required to do the subsurface exploration, and all that. So today we'll be discussing some of the questions. Okay, so the first question that is there is, the investigations performed using the trial pits are generally limited to a depth of. Okay, so in the beginning only, what we have discussed is the trial pits, right? If I can share this screen. Okay. Can you see this screen? Okay, so it's still visible. Okay, I will record this. Stop. Okay, I think you can see the screen, right? Yeah, can't see the screen. Why? Can you see what I'm writing? No, right? Why it's not working? I'm sharing still. Yeah, I think now you can see. Yeah, now you can see. Okay, so what I was discussing about the trial pits. See, there are several method of investigation, right? Investigation in the sense of what? Investigations for the the exploration or the investigation of the subsurface. Okay, so in this, what we do, how we collect the sample, how we need to understand the subsoil properties, like what are where is the water table and all that. So for that we need some kind of investigations. Okay, so for that we have several investigations such as trial pits. We go for trial pits or trenches. Okay, trenches. Why do we do this trial pits and trenches? This is to know that what kind of soil is there. Okay, and others are like, we do go for borings or drillings. Okay, borings and drillings are for soils and rock for the larger depth. Okay, and we go for geophysical or geotechnical investigations. Okay, so now this trial pits or trenches is one kind of preliminary investigation or preliminary investigations that we need to understand on the site. Last in the last discussion that we have covered was the preliminary investigation and detailed investigation that we have to go before going for the subsurface exploration on the site. Okay, after we have all the preliminary investigation, that which site is to be explored, and what are kinds of small preliminary investigation that we have done, right? Reconnaissance survey, study of maps and all, and what kind of detailed investigation that also we have covered. So now first we need to go for trial pits or trenches for shallow depth. Okay, we'll come to this. This is the preliminary investigation, and these two are the detailed investigation. Okay, so now what was the question? Where is that? Okay, so the question was investigate. You can see it. No, you can see it clearly. So you can see investigations performed using trial pits are generally limited to. See, as I said that the trial pits or trenches. Okay, it's fine. It's fine, Carol. Okay. Okay, so what we are saying is, we go why these investigations that are performed using the trial pits or trenches are generally limited to how much depth, right? So as I said in the beginning only, that we go for this. What kind of trial pits is this? See this kind of picture, this hole or this cutting that you can see is the trial pit. So you can see this is not that much depth. Okay, so we go for the trial pits for around, it is a open type of trench, and we go for maximum of 2 meter to 3 meter. Okay, so what here we are doing, here we are doing the shallow investigation, sorry, shallow excavation. Okay, so what we do, we dug at the site with the reference to some structure. Like in the surveying, what we do first, we need to understand that okay, with this reference we have to have some point chosen where we will do this trenches or the trial pits. Okay, let the reference can be trees, buildings, or if any benchmarks and all are there. Based on that, we'll point out which point we need to do the exploration or the investigation, and then there we'll do this trial pits. Okay, so this will be why we are going for shallow depth. Any idea why we are not going for deeper? Like we have other investigations, right, after this borings and drillings, but why we are going for shallow investigation? We can only go for deep investigations. Anything?
Just to know which type of a strata is there.
Okay.
After that, we can decide which type of machine or equipment we can use for further investigation.
Okay, but as I said, in the trial pits, it is a shallow depth investigation, right? So in the shallow depth investigation, we can't know the strata below the 2 to 3 meter depth. So the layer stratification
But
is,
we can, but
yeah,
we can get an idea.
yeah, idea we can get. Other than that,
Uh,
what we can know the properties, characteristic properties of the soil, such as the like in that too in the natural condition, because in the top layer only we'll get what kind of moisture content is there, because after some depth we'll get the water table, right? And in the shallow depth you can have the soil. If you can get the soil in undisturbed state, it will be much better, because you can go for shear strength, bearing capacity and all. Okay, so main thing is it is accessible in the natural condition of the soil. Okay. Okay, so so the what will be the answer for this? Investigation performed using the trial pits are generally limited to a depth of, your options are
uh,
one less than 1 meter, greater than 5 meter, less than or equal to 3 meter, or 2 meter.
so less than or equal to 3 meter.
Okay, anyone other than Nazrul? You can write in the chat box also if you want. Anyone? Okay, as I said, for the trial pits we go for maximum of 2 to 3 meter, so it will be below 3 meter. Okay, so the answer will be less than or equals to 3 meter, that is C. Okay, so as we go downwards, what will happen? The cost for the excavation will increase. Okay, and if we go for more depth, and let us say here in the picture you can see that it is kind of clay soil or some kind of cohesive soil. But if it is cohesionless soil, what will happen? If we are going for greater depths, it can fall down, right, in the pits. So what we have to do, sometimes we have to go for bracings also. Okay, so this kind of investigation is suitable for small projects. Okay, let us go to the next question. So the question is, which type of boring method is most suitable for subsurface exploration below the groundwater table? Okay, before this, tell me what are the types of boring? Like, okay, before that, what is boring? See, we have learned the term boring and drilling. Okay, So both are like similar. We go for excavation at deeper depth, but there is one difference between boring and drilling. What is that? Anyone?
Sure. Boring is generally done for soil and drilling is for rock.
Correct. So when we go for boring, we go for the soil excavation at deeper depth, and drilling is for rocky kind of thing. Okay. So now coming to boring. Okay, in this question it is mentioned that which type of boring method is there. So there are several kind of boring methods. Can you name some of those?
Yes,
So
four kind.
four
Uh,
kind. Okay. What are those?
yes, first is auger boring. Second one is wash boring,
Hmm.
and third one is percussion boring,
Okay.
and fourth one is rotary boring.
Rotary drilling. Okay. So what is boring? Boring is simply the process of making a hole for exploration of subsurface medium. Okay. We need to understand the subsurface medium, the properties, the capacity and all. And to collect the soil sample to do the investigations, we do this boring. Okay. Generally this boring is for 150 millimeter. It's not hard and fast rule that we have to go for 150 millimeter diameter, but generally it depends from site to site. Okay, it's not like 150 millimeter is the standard one, but generally people use this. Okay. Okay, so to understand the soil or the rock type with the depth, we go for this type of boring or the drilling. Okay, other than understanding the this soil types or rock types, what for what reason we go for this boring and drilling? Anyone? We also observe the groundwater table, that where is the groundwater table located. Okay, and other than that, let us say in the trial pits only you have seen, right? Here you can see that there are several layers. Here you can see some other color is there, and at this portion there is some other color, again at this portion there is some other color. Okay, so now see, at one point we saw that okay, these are our layers, but what can happen, there can be possible fluctuations in the stratification, right? What I mean is, see, let us say this is my lateral, and here we have done the test pit. Okay, here we can see some different layers, but what can happen, it can go like this and this, and then again it can go like this layer can go like this, right? So if you again go for some other location, you will find the layers but at different depths. It can be see here, if you go here, the fluctuations is different. Here the depth is this much, let us say 1 meter. Okay, here again if you see, it will be something like 2 meter or something. It's not to scale. Okay, so this type of possible fluctuations can happen in the stratification. So to understand this, what do you think what we can do? See, I don't want this class to be boring. Okay, it's better that we guys interact with each other, then only if you have any doubt coming and all, we can discuss among each other. Okay, this is not kind of lectures that you are seeing in the videos and all. Okay, this is kind of discussion and interaction session. So if you can interact, it will be much better for both of us. Okay, it will clear your doubts also, and so that you can do the assignments properly and all. Okay, so what I was asking, so see, there are this possible fluctuations in stratification. How we can deal with this problem? Any idea? Any guess?
By having number of boreholes, literally also,
Okay.
depth wise also, literally also.
Yeah, correct. So what we have to do, we have to go for multiple boreholes. If we do, see, if we do the borehole here, let us say B1, we have to go for B2, P3. So if we go for multiple number of boreholes, then we can observe, okay, these are the possible fluctuations, and now we can understand, okay, this at this point this type of fluctuations is there, and it's not like every point, every 1 meter you have to go, but at some interval you can go, so that you can understand the fluctuations, that what kind of curve it can have. Okay. Okay, so the question was, so what will be the answer for this? Which type of boring method is most suitable for subsurface exploration before, sorry, below the groundwater table? As Nazrul has
Wash
said,
boring.
right? There are
It it it's a rotary drilling.
but see what it is saying is below the groundwater table, right? Rotary drilling mostly we go for rocks and all. If we need to only understand the most suitable boring method, which will be for the when the we need to understand what is there below the groundwater table or where is the groundwater table, then for what we'll go for the wash boring. Okay, because okay, wash boring will cover. Okay, so answer will be wash boring. So in wash boring what we do, anyone? Yeah, correct. Mr. Neil Grip, it's correct. It will be this wash boring method only. Now why, what happens in wash boring? Anyone?
As you go down, soil fragments plus water comes out. So
Yeah, so
we can see the change in color,
okay,
how it changes, and
so
type of the soil change
yeah,
also can be visualized.
okay, correct. So that that thing, that mixture, it has some name. What is that? Which is coming out with the water?
Slurry.
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 Correct, correct, correct. So what we do, we go for the exploration with the boring rig. Okay, and what we see when we are rigging it out, what happens? The soil, whatever is there, will also come out with that. And what we can see in the wash boring or any method is that as we are digging it up, what will happen after some depth? What will happen? The layer will change, right? Now when the color of that slurry is changing, then we can understand, okay, after this depth some other layers is coming. Okay, and based on the color we can identify what kind of soil is there. Okay, other than that, let us say we with the change in the slurry color we can understand, okay, this kind of soil is there. Anything other than the change in slurry color, we can understand, okay, there can be a different soil layer. We are boring, right? So when we are boring, we need to understand that, okay, now the stratification is changing. Other than the change in the color of the slurry, is there any factor where we can say, okay, with this we can say, okay, the soil layer is changing or something? Any guess? One is correct, that if the color of the slurry is changing, we can understand that the soil layer is having some different layer. Anyone? No, okay. See, when we are boring, so what will happen? We have a rate of boring, right? Like with some rate, we are doing the boring. So if the rate of boring is changing, let us say we have some clay soil. After that, there are some rocks. Okay. So now the rate of boring which was there on the clay soil, if with the same rate we are going for the rock, will it work? No, right? Because if we are going for rock, it's a hard material, so we have to increase the rate of boring. Okay, or if we are using the same rate of boring, what will happen? The rate of boring will reduce when we are going for the layer which is having the rock layer. Okay, so so for what kind of soil do you think this wash boring is suitable? Is it suitable for gravels and boulders?
No,
See, for gravels and boulders, we can't use washboarding because in the washboarding, what we do, we use the clay soil. If we are having rocks and all, let us say gravels, boulders and all, we can't dig it like with the that rig. Okay, so this washboarding is very much suitable for soils like cohesive soil, the clay soil, silt, and soft soils. Okay, so for the gravels and boulders, we can't go for wash boring. Okay, next question, what is that? Okay, the answer will be wash boring. Next question is, which type of samples are required to examine the shear strength of in situ soil? Options are undisturbed sample, representative sample, non-representative sample, or both B and C. Okay, before that, what is soil sampling? Okay, the soil sampling, what is soil sampling? Anyone? Anyone?
We are
It's just
taking,
simply
yeah,
Yeah, yeah, go on, go on, one by one.
taking the soil sample from the boring.
Okay, okay. Okay,
Simply.
so the
Uh,
soil sampling is simply the process of obtaining the samples of soil from the from any desired depth, that we want to understand at this depth what is the soil, at this depth what kind of soil is there. So the soil sampling is simply the process of obtaining the samples of soil from the desired depth at desired location, whatever location that we want in a natural soil deposit. Okay, and why we are doing sampling? To understand the engineering behavior of the soil, right? So that we can have a proper design for the foundation or any structure if we are going to build below the ground surface. Okay, so for that we need the soil sampling. Okay, now this soil samples, if you see, the soil samples can be divided into two. First one is the disturbed soil sample, and the second one is the undisturbed soil sample. With the name only you can identify that disturbed sample means what. First of all, there is nothing called undisturbed sample. Okay, because even whenever we are going for sampling, we are taking it from the ground, it will have some kind of small disturbance in the soil sample. Okay, so undisturbed sample are what? The undisturbed samples are the soil samples. When we are collecting that, let us say what we are seeing is, if we are going for this test like moisture content, or what is the water content of the soil, then what is the structure and void ratio of the soil, if all these are having same property, okay, then we can say that the soil is undisturbed soil. And when it is undisturbed, sorry, when it is disturbed, when this kind of thing is not there, like we can't say that the same water content is there everywhere and same kind of structures is there or void ratio is there, then we can say okay, these are the disturbed sample. Again, if we divide the disturbed sample, we have one is representative sample, sorry, representative sample, and the other one is the non-representative sample. Okay, so what is representative sample and what is unrepresentative, sorry, non-representative samples? First, as I said, what is disturbed sample? Disturbed samples are like after collection of the sample, if the water content, the void ratio, the internal structure or the chemical composition are getting changed from the original, if at the site we have some water content and the samples that we have taken, if that and this the original one is having some different water content, different void ratio and different internal structure and chemical composition, then we can say that this sample is disturbed sample. Now coming to the representative samples, if the soil samples are having the structure and chemical composition same as at the site, and like as the site, we have the soil sample, soil at the site, and we have the soil sample. Now if the internal water content and void ratio are not same, that we have seen, but the internal structure, the chemical composition of the soil is same as that of the site, then we can say that this sample is representative soil sample. Whereas if everything is changed, then we can say that this is non-representative soil sample. Okay, so what was the question? Okay, so question was, which type of samples are required to examine the shear strength of in situ soil? What will be the answer? What do you think?
so undisturbed sample.
Why undisturbed sample?
Properties are not changed.
Yeah, correct. Because as we are taking it from the very shallow depth, we can say that this properties, the engineering properties, whatever water content and all are there, that are not changing, we can use that to have the shear strength, because what we are saying that internal structure and all are also not changing. So for that we can test this shear strength of the soil also. So the correct answer for this will be undisturbed sample. Okay. Okay. Next. Next question is which type of soil requires less time for groundwater to reach its equilibrium level? This is simple question. Okay. Like let us consider one bucket. Okay. We have one bucket. In that we are putting this sandy soil, clay soil, whatever. Okay. And we are having one outlet here. This is outlet. Okay. Now we are putting water here. Okay. Let us say this is the groundwater. Now the question is which type of soil will require less time for the groundwater to reach its equilibrium level. Okay. Now, okay, we should not put this. Wait. Okay, where it is? Sorry. Uh, Let us say the groundwater table is somewhere here. Now we have done the boring. Okay, so what will happen? The water from it can have some drawdown curve. Now this drawdown will get some equilibrium level somewhere, right? So what do you think, for which soil sample or which soil the groundwater will reach to its equilibrium level very fast?
That sandy soil, sir.
Yeah, Gitu also answered. Yeah, it's sandy sample, sandy soil. Why not clayey, silty or loamy?
The permeability,
Yeah.
sandy soil is have a high permeable.
So they have much voids. That's why the groundwater
Yeah.
can easily percolate, and then we can have the equilibrium level. Okay, this was simple. Sandy soil. What happened? Okay. Next question is which type of rocks is primarily available on the surface of the earth? Simple. This is also simple. It's like what kind of rocks are there? You might have studied that those are igneous rock, sedimentary rock, metamorphic rock, and all. So the question is which type of rocks is primarily available on the surface of the earth?
Igneous.
Uh,
Sedimentary.
Sedimentary. Any other answer?
So sedimentary rock.
Okay. So the question, if you read properly, it's is saying that which type of rocks is primarily available on the surface of the earth. Okay. In the igneous rock, what we have seen is it is like 95% of the crust is having that soil or that igneous rock. But the question is which type of rocks is primarily available on the surface of the earth. Okay. So if you have gone through the lectures properly, it is like 80% of the rocks. Okay, 80% of the rocks, not the soil. Okay, 80% of the rocks are having the surface of the earth. Okay, so as per whatever information the people or scientists or geophysicists have gone, they have got about 95%. Okay, I will write, where is my pencil? Okay. About 95% of the total crust. Okay, the whole crust is composed of the igneous rock, whereas the more, like not 80% or more than 80%, more than 80% of the rocks that are available at the surface of the earth, or at the earth's surface, are sedimentary. Okay, so the correct answer for this question will be sedimentary rock. Okay, what happened? Okay, next question is, any other question I have for you guys? Okay. So before going to this, we do rock sampling. Like we go for boring and drilling, right? So there, the soil sampling that we have learned is okay. That we are going for soil sampling. But when it comes to rock and all, we go for rock. Okay. Oh, sorry. I'll write in some different one. Where is that? Yeah. So what we do, we go for rock core drilling. Okay, so as we have learned that boring was for soil and drilling was for rock, right? So what we do in this rock core drilling, we just simply like rock core drilling is simply the collection of the sample of rock that is underlying the area of interest wherever we are doing the drilling thing. If there is a sample of rock that is stratified, then we go for that collections. Okay, so why this rock sampling is required? Why the
We need,
rock sam? Yes, go on.
we need to know the quality, strength, etc.
Okay, quality and strength of the rocks, right? So mainly this so you said quality and strength. Okay, so quality and strength to access what? To access the characteristics of the rock. Quality and strength are what? Are the characteristics of the rocks in terms of it might be have some fissures, cracks, strength, or porosity, all that. Okay, so all the characteristics. Other than this, these are also characteristics. Other than this, we can go for porosity, whether there are cracks or not, all that. Okay, so what was the question? What is the question? Okay, so what we do, we go for rock sampling for to understand the characteristics. Now this sampling of rock, what we do, we need to understand the quality, and to understand the quality we have two terms, or you can say one term, that is rock quality designation, and other than that we go for this total core recovery also, but mainly it is rock quality designation. What is that? It's we should write there because I don't have space here. Okay, so what we go, what I was saying is rock quality designation, or we can say RQD. So what is rock quality designation? The rock samples that we have taken, whatever the rock sampling we have done from the drilling, so from that we understand the quality of the rock and its strength characteristics, as I said. So what can happen, this rock sampling when we are doing, no, it might be possible that we are not having only one single piece. Okay, but it is recovered in some segments. Okay, there are some different rocks, we can have some different segments into smaller pieces of the rock. Okay, so depending upon the strength, its suitability as the foundation, we are accessing all this. Okay, so what is RQD, or rock quality designation? It is a rock mass classification factor. Okay, which measures the overall quality of rock core. Okay, so you understood why we need the quality of the rock. Okay, so that we can understand, we can design what kind of foundation we need for our structure and all, right? Okay, so this rock mass classification factor, or this RQD, is given by ISRM 1981, and for them the standard size was near to 54 to 55 millimeter diameter. Okay, you can check this in the lecture. Similar some in between this 54 to 55 millimeter diameter and 150 centimeter length. Okay, to understand the RQD. So now how we can understand this RQD, we have to give some uh, quantity for that, so we can understand what kind of quality the rock is having and all. So how we find this RQD? Let us say we are doing the sampling. Okay, so we have different layers or segments, as I said, some, let us say like this. Okay, something like this, let us say we got this. And where we write this, as we move, what we do, we use the board log. In the survey also, what we do, in surveying, you might have studied, what we do is we go for the what was that book, log book or something, right, where we write, okay, here we have this point, from this there are some offsets. Similar to that, here what we do, we have a board log. Okay, and we can used to note down this layer is at this depth. After that, this at this and this depth, we have different kind of layer, is this this rock or this kind of soil, whatever is there, with the depth, with the name of the layers and all, we go for the board log. Okay, and then we find out the RQD for the rock. So let us say we have the whole this whole is the core. Okay, what we are doing, rock core drilling, right? So we are going for, let us say, 150 centimeter depth, or some kind of some depth. Okay, we are going for 150 centimeter depth, as I said. See, we have 150 centimeter length of the core drill. Okay, now we are let us say we are going for only 125 centimeter depth core. Okay, and here we have different kind of layers. Okay, so how we find the rock quality designation? It is something like total length of core sticks that is longer than 100 millimeter. 100 millimeter means 10 centimeter, divided by the total length of the core run. So as per ISRM 1981, what is the total length of the core run? It's 150 centimeter. Okay, okay, so we'll do some problem, and based on this RQD, the value, whatever the value we are getting for RQD, we have one table, or we have one classification, that if it is 0 to 25%, the rock quality is very poor. If it is 25 to 50%, it is poor. It 50 to, like, it's like 0 to 25 RQD quality is very poor. If we go for 25 to 50, sorry, if it is 25 to 50, it is poor. If it is 50 to 75, it's good or fair. Then 75 to 90, it's good. And from 90 to 100, it is very good or excellent. Okay, now based on this percentage, we define that whether this rock quality is good or not. Okay, so based on that, we'll do the question. Okay, so what is the question? The question is, during rock sampling, a 150 centimeter length of rock core was drilled. Okay, the core recovered from the drilling operation is shown in the figure below. I will show the figure. Determine the rock quality designation for the rock sample. Okay, so if possible, you guys take some pen and paper and start doing this. Okay, so that if you have any question, if I just do and show, it will be not be that much useful. Okay, if you do, it will, what happened, showing, right? Okay, so the figure of the drilled core, you can see that the total of 122 centimeter we have drilled. Okay, and the total length of the rock core is 150 centimeter, and the segments, you can see the segments are noted as like A, B, C, D and E. Okay, now you have to go for the rock quality designation. The formula I am writing again. The RQD is written as total lengths of core sticks longer than 10 centimeter divided by the total length of core run. So you guys take some pen paper, start doing this. Let's see what answer we get.
93.4.
93.4. Okay, anyone other than Sarath?
Yes, sir, 93.4.
Two votes for 93.4. Anyone?
93.4%.
Okay. Can anyone like say how you have done that? Let's see.
Yes, sir.
Okay. So
The simply we have added the piece which is larger than 10 centimeter in length.
okay.
So it is 34 centimeter plus 15 centimeter plus 37 centimeter plus 28 centimeter divided by 122 centimeter
122.
multiplied by.
What is the
Yes, sir.
total length of the core run? Total length of the core run is should.
Okay, total into 150 and okay, sorry.
So how much
And
you are
in the
getting?
given figure it's one.
Anyone other than Nazrul? Is this the way we have done?
76 I am getting.
How much you are getting?
76.
Seven,
76 is
76,
not there
76.
in the option, right? So I don't think that is the answer. Anyone? Uh, Srinath, did you do that?
Yes, sir, it's giving 76.
76 only. Okay, but 76 is not there in the option, so that might not be the correct answer. So you are doing like this. You are getting 76%, right?
Yes,
And
sir.
before that, you are using here 122, and then you are getting something 93.4%, right?
Yes,
But
sir.
in the formula, we have total length of core run. That should be 150 millimeter. But still, you are not getting 76%. Mr. Shatish, like this type of question was there in question 9 that you are discussing.
Uh, no, no,
Oh,
it is
that was
different.
different. Okay, okay, okay,
Yeah.
fine. So see, why you are not getting something which is there in the option. The point is the layer that D you if you see here the segments are so much broken that each of the segment is much lesser than 10 centimeter. You can see, right? If this is 37 centimeter, if you divide into 3 also, all the segments that are there that are very small, it is very much less than that of 10 centimeter. So you can't count this. Okay, so this 37 that you are taking should not be there.
Yes, sir.
So what is the answer?
51.3%.
Everyone are getting 51.3%. Okay, Gitu is getting 51.3%. Mr. Nilgrieve, did you do that? How much you are getting?
Yes, sir. 77 divided by 150, that is equal to 51.3.
Okay, so all are getting 51.3%, right? So that is the
Yes.
correct answer. So you got why we are not considering the 37 centimeter or the D section, right? Everyone?
Yes,
Yes.
sir.
Okay,
Clear, sir.
okay then. Okay. So the answer is 51.3%. Okay. That's why I have given 93.4%. When I was doing this, so on that time I saw 93. That's why I increased one of the options. Okay, let's move. Next question is which of the following auger can be used to collect the samples from cohesionless or dry sandy soils? Okay, first of all, what kind of augers
Sir,
you see?
sir,
Yes.
sir, may I ask you one question, sir?
Yeah, go ahead.
From the previous, yeah. Sir, if in the last question,
Hmm.
uh, as we know that there are different machines available for core drilling
Okay.
in the market.
Mm-hmm.
Uh, so if we drill the core mm, by high quality of machine,
Hmm.
then we can get a sample which is 10 centimeter in length in the more number.
Hmm. Hmm. Hmm.
But in the same strata, if we use the low quality of machine,
Hmm.
where any contractor or any client is using the low quality of machine,
Hmm.
then fracture and cracks will develop more.
Hmm.
Then there we will get a low RQD.
Yeah. So, what is your question is whether should we go for the high drilling machine or should we go for low drilling machine? Plus, if we are going for low drilling machine, how will the RQD will change? Something like that, right?
Yes, yes,
Okay. So the first thing, the high quality drilling machine and the low quality drilling machine Obviously, if you go for high quality drilling machine, the samples you will get, the data or the observations that you will get, it will be much accurate. Okay, so the RQD you'll get will be much accurate than that of the site. Okay, now for that reason only the RQD is given in range. Okay, if you have seen in the, where is that, here, if you see that the range is given from 0 to 25, it is very poor, it's 25 to 50, it is poor. Okay, so in many a case what will happen, if you are using low quality drilling machine, the RQT will not be very much accurate, but yes, it can give some insights about whether the quality is poor. Because if you go for, let us say, the high quality machine, it can be like it is coming as 32 or something, so there we'll understand, okay, the rock is poor quality. But again we are going for higher, let us say it came, we understood that it is not 32, it is 51 or something. Okay, let us say that case. Okay, then we can say that, okay, this can be a fair quality rock. Okay, but when it is 50 to 51, no, like very near to the lower range or the upper range, we go for some one more kind of options. Okay, like we are getting some RQD as 51 or 52%, so that is near to the lower range of the fair quality and the higher range of the upper bound of the poor quality. So for that, then we go for some other methods also, whether the RQD that we are getting is correct or not. I think your doubt is clear.
Oh, yes, sir. So that's why it is given in the range.
Yeah, yeah, yeah.
Yeah.
Okay,
Okay, sir. Thank you.
okay, okay. We'll move to the next question. Okay. Ah. So what I was asking is, which of the following auger can be used to collect the samples from cohesionless soil or dry sandy soils? First of all, there are several kind of augers that is present in the market. Some of them has been discussed in the lectures. Okay. Anyone can say what all augers are there? What kind of augers are there? Anyone? You can write in the chat box also if you are not able to speak.
Screw auger, Dutch auger,
Okay,
bucket auger,
bucket auger, then
plain auger,
planar auger. Okay,
stones, planar auger, and stones, soil auger.
stream soil auger, stone catcher, and all that. Okay, so now we are asking that the samples that we have collected, whether no, for the samples to be cohesionless or dry sandy soils, we know the samples are cohesionless or dry sandy soils. Which auger we need to use? Okay, so the options are this. I have not given the name. Can anyone say which is the first one is which kind of auger?
Screw.
Yeah, correct. It's screw kind of auger. The second one, that is B. Which kind of auger it is? Anyone?
Dutch auger.
Ah, correct. Dutch. Is it Dutch auger? Who said Dutch auger? Sarath, right?
Sir,
Ah, yeah,
yes.
yeah. So I see. I'm asking again. This doesn't mean that is wrong or something. That is Dutch auger only. Okay. Okay. Next is which one? This one is stone catcher, and the last one D is, it's kind of cylinder, right? It's kind of bucket. Say it is bucket auger. So for cohesionless soil, what do you think will be the answer? Cohesionless soil or dry sandy soil? See, in the picture we can see the second option, that is the Dutch auger. We are using the clay soil, so that is not the answer.
So bucket auger.
Bucket auger, correct. So bucket auger is also called as the barrel auger, or barrel because it's kind of barrel or cylinder. Okay, barrel auger. So many names are there. Barrel auger, then something core auger or something we call it. Okay, so this is form. This is, like you can see, this is in the form of cylinder, right? So what it do? It will like hold the soil within it by means of cutting lips, like in the lower portion that you can see, right? It is kind of cutting lips, it's kind of this. Okay, and when you will bore that, or you will use that, it will cut the soil and it will take the sample in that cylinder. Okay, and it can be used for any types of soil. It can be used for any type of, let us say, for dry sand, for specific kind of bucket is available. Okay, so whether for cohesion less soil this bucket auger is applicable. Why not Dutch auger? In the figure we can see that is fine, but what kind of soil we use for Dutch auger? Gitu also said bucket
Only
auger.
for clay soil.
It's for clay soil. Like why we are going when we use this Dutch auger, when we need the soil samples when which are very at very shallow depth. Like we need to understand the which are the highly fibrous soil, or like swampy areas are there. There we use this type of soil. So that are not suitable for the dry and sandy soil. Auger also, auger this screw auger, we know it is also called spiral auger because it's kind of spiral, right? So it is used, it is also used for cohesive soil or soft soil. And the stone catcher, when we use stone catcher we use for the large rocks. Okay, large rocks kind of thing. So the correct answer will be bucket auger. Okay, see this one. What is the next question? Next question is, calculate the sensitivity of clay if the shear strength of remolded soil and the undisturbed soil was found to be 15 kilonewton per meter square and 30 kilonewton per meter square. What is sensitivity? Anyone? Sensitivity of clay.
uh, unconfined this strength of remolded soil divided by that for undisturbed sample. So ratio will be 2.
Okay, but with the sensitivity of soil, physically what do we mean? Like if some soil is having less sensitivity and one soil is having high sensitivity, what does that mean?
Depends on the extent of disturbance due to remodeling, etc. Structure gets disturbed,
Correct.
particles
So
get reoriented, so strength.
yes, if the clay is with some load only, if it is getting much disturbed, it is less sensitive. If it is, if one clay is there, if we are giving same load and it is getting not that much disturbed, then we call that as much more sensitive. Okay. So as Mr. Satish said, the sensitivity of clay, how we can get sensitivity is given by the unrent shear strength of undisturbed sample to the shear strength of remolded sample. What is remolded sample again?
If you are
Disturb
taking
sample.
sample,
One by
if you
one.
are taking sample at a very high speed of rotation, then remodeling takes place.
Uh, what what is remolding? Like that we can understand that, okay, with the high speed and all remolding and all. But what is
So
remolding? Yeah.
I think the remolding sample will be that sample
Hmm.
in which we have acquired the same. We have tried to acquire the same density and same moisture content of any undisturbed soil sample, uh, so that we can achieve simulate that sample to the real sample that is really existing in the ground.
Um, but let us say at the site only we are saying that this soil is remolded soil. Then it is kind of what to say. Let us say that in past that soil sample is having some load. Okay. Now again we are giving the same load. Okay, and it is getting that shear strength. So for that sample we say that okay, this is remolded sample, and the shear strength that we are getting is for the remolded sample. So as he said, Mr. Satish, that it will be something like 30 by 15. Answer will be 2. Okay, so the sensitivity of clay also we have some different range that, okay, less than 7 it is less sensitive, not sensitive. From 7 to 17 I guess it is less sensitive. Greater than 17 it is highly sensitive or something like that. Okay, so answer is 2. Next question is from Venn shear test. Okay, in a Venn shear test, torque of x newton per centimeter and all. Okay, so firstly, why we do Venn shear test? Before that, okay, let me. So what we do, we go for this kind of test. Test can be like Venn shear test and all. These are semi-direct method. Whatever for now we have done, those are the direct method of investigation. That trial pits, boring and drilling and all. These are the direct method that we are doing to understand the subsurface layers, all the engineering behaviors and all. Okay. Now we are going for some semi-direct geotechnical investigation. Wait, okay, geotechnical or geophysical investigation, what you can say, investigations. So under this there are several methods such as Venn shear test, then SPT test or standard penetration test, then we have cone penetration test, and then we have dilatometer test, and we have pressure meter test, and so on. Sorry, pressure meter test and so on. Okay, so in the week 2 lectures I think he has completed up to Venn shear test and SPT also he have not gone through the problems I guess. So first is the Venn shear test. So Venn shear test is done for
In situ, undrained, shear strength.
to understand the
Basically for cohesive soils.
yeah, correct. So when shear test we go for the cohesive soil, that too very plastic cohesive soil, very soft soil. Okay, so now this Venn shear test is done for what? Venn shear test is done for understanding the in situ, sorry, I'll change the color, in situ undrained okay, undrained shear strength, to understand the undrained shear strength of any, mainly the cohesive soil, or if we say the plastic cohesive soil. So Venn shear test we do for only for this type of cohesive soil, or we can say the soft saturated soil. Okay, so now for this we use the that what to call Venn the okay, I will show the apparatus. So this is what we call vein. Okay, here you can see that these are the vein blades, the 4 vein blades you can see. Okay, sorry, vein blades, and the upper one, this one is the vein shaft. Okay, so what we do, we put this inside the soil, sorry, inside the soil like this. Okay, the first figure in your left you can see. Okay, okay, so here what we do, we insert the vein rod or with the vein blade, and then what we do, after we go up to the desired depth, we rotate it, or we give a torque to the vein rod. Okay, after giving the torque to the vein rod, what we get, let us say we gave the torque like this here, torque T you can see. So what will happen, this will rotate, the shaft will rotate and the vein blade will also rotate. Now let us say this is the soil, and you are putting this and doing this, we are giving a torque to this. So what will happen, all to all the periphery of the vein blades will have some kind of resistance, right? So to all the vane blades will have some kind of resistance to all the periphery. Okay, sorry, the torque is this side, so the resistance will be that side. Okay, how to okay, so the torque is this side. Okay, so the resistance will be this side on the periphery of the vane blades, correct, like that. And other than the periphery of the vane blades where all resistance will be there, you are putting the vane rod inside the soil, so on the bottom also and on the top also you will get some of the resistance, okay, on this area and this area, right? So we'll get the shear strength from this. So from this all the resistance that we have, if we add all the resistance, then we'll get the torque, right? The torque is basically giving the resistance, so from that we'll use the formula and then we'll get, let us say, if we see, not here, okay, we'll do in this determination of the you got like what happens when the vane rod is inserted and when we give the torque, right? Then we will go for this, how we are determining the shear strength, what happens, like how the resistance happens, where all the resistance happens. You got that, right? Then we'll move to this determination of shear strength. Okay, I'm guessing that you all got the how the resistance is working. Okay, so what we have seen was, this one was the vane rod, let us say these are my vane blades. If the drawing is not proper, you can understand, right? Let us say okay, some kind of this kind of structure. Now what will happen, the resistance will be this side. If we are giving the torque this side, resistance we are getting, okay, let's say the height of the vane blade is h, the total diameter of this is d, okay. Now from the radius how much will be, it will be d by 2, right? Now this torque will be equals to the resistance that we have got from the vane blades, or you can say the periphery of the vane blades, okay, against the rotation of the vertical edges, plus the resistance due to resistance from the top and resistance from the bottom, okay. Here also you'll get one resistance, here also you'll get, okay. So now the resistance of the vane blades, how will we calculate? See, it is happening towards the periphery of that, right? For the whole of the vane blade, towards the whole length of the vane blade, which we have considered as h. So it will be like pi d will be the circumference into the height into the shear strength. Because of the shear strength, it is giving resistance. So let us say the qu is the, let us say qu is the shear strength of soil, okay. And it is giving torque based on what, till the iron rod, right? So it will be d by 2, sorry, plus for the top and bottom, what we'll do, we'll integrate from 0 to d by 2, sorry, it will be like the whole circumference into, or we can write in the d format also, okay, we can write in the radius form also, because anyway we are giving the limits from d to d by 2, so 2 pi r dr into the length, that is r. And as we are doing for top and bottom, so we are multiplying 2, So from there you will get something like pi d square h into qu, pi d square by 2, pi d square h qu, plus 2 into 2 pi into qu. Okay, this would be into qu into, how much it will come? R square means r cube by 3, r cube by 3, 3 3 2 it will come as something like d square, r cube by 3, this would be d cube by 24, something like that. Okay, okay, so from this we can simplify this also. Okay, it will be pi d square h qu by 2 plus 2 is a 4, 4 6 is a 24, pi qu d cube by 6. Okay, this one will be our final equation. So now this we can calculate the shear strength if the torque is given, and if the diameter is known, and if the height of the vane blades are known. Okay, so let's move on to the question. So the question is, in a vane shear test, a torque of x newton centimeter, okay, torque is given as x newton centimeter, is required to cause the shear failure of the soil in situ condition. After that, the vane was rotated quickly to cause the remolding in the medium, and again a torque of 20 newton meter was reported at the same time, same location and depth. The vane is given as 65 millimeter in diameter, so the D is 65 millimeter, and 133 millimeter 130 millimeter long, so H is 130 millimeter. Okay, the sensitivity of clay is found to be 3.12. What is the value of x? So what is the question? It's like a torque of x newton centimeter is given, and see we have the diameter and the length of the vane, and it will cause some shear failure in the soil. Okay, now again after that, again what we have done, the vane was rotated quickly to cause the remolding in the medium. Okay, and again one torque of 20 newton millimeter was reported at the same location and the same depth. So what will be the value of x? Can anyone do that? We'll keep some 5 minutes and all, it will take some time, I guess. Formula, if you want, I can open. First you note down the data, then if you want I can open the formula, or if I can write it here, it's like t equals pi square, what was that, pi square t, sorry, pi d square h q u by 2, t equals pi d square h q u by 2 plus pi d cube q u by how much, 6. Okay, do it. Let me know if anyone has done. Okay, just don't do and sit idly. If you do this now, you will get the doubt if you have any, so that you can do the assignments.
I think it is 62.4.
62.4 unit Newton centimeter you are saying. Okay.
Yeah.
Okay. Anyone other than Mr. Shatish?
6240.
Okay. Anyone? Anyone else?
It is 6250. I revised
6250 or something. Okay.
6240.
6240.
6240. Okay, so let me do that. Okay, so what was given was how much it was given. D was given as 65 or something. 65 and 130. Okay. It was millimeter, I guess, and 130 millimeter, and it was given as something shear strength was given for remolded. Yes, for 20 Newton meter for the torque. Okay, so for remolded case or remolded sample, we have T equals to 20 Newton meter. Correct. Okay, so now you'll put that equation here. So it will be like 20 equals, or T equals, what was that, pi into d square is how much. I can see that was in millimeter, and here we have in meter, so we'll convert this into meter. 10 to the power minus 3 whole square into h is given as 130 into 10 to the power minus 3, because we are converting into meter, into Qu, the shear strength we don't know, divided by 2 plus pi into Qu into t cube. D is how much? 65 into 10 to the power minus 3 whole cube divided by 6. Now from this we'll equate the shear strength, right? How much you are getting shear strength? I have to do the calculation, or maybe if you can tell me if you have done like this.
For this particular problem,
Mm-hmm.
we don't have to do these calculations because QU is common in both
Yeah.
and other parameters are the same. So we don't have to calculate D and all those things. So QU into that sensitivity factor and we convert into our units. That's
Okay,
all.
so what you are doing here is you're keeping it in QU factor, right? So it will come as something like some constant into QU. Okay, and sensitivity is given as something, what was that,
3.12.
3.12. So let us say the sensitivity is
So
given as,
simply we multiply and convert
yeah,
into
it's like
Newton
QU
centimeter.
undisturbed divided by QU remolded, as we have seen in the last problem. It's like 3.12. So QU undisturbed will be equals to the sensitivity into the QU remolded, and this is remolded. We'll put that here. Okay, so the sensitivity, okay, let me do the calculation once.
this value given is for remolded case.
Yes, yes. So
So we have to multiply that with 3.12
yeah, that is what I have written here, right? Here 3.12 into the
and convert.
QU remolded, and then if you know this, we'll have something like SU. Wait, give me 1 minute. Let me do the calculations. Okay, so it is coming something like 484. Sorry, no, how much? 4824 1 point coming something like 48241.81 Newton per meter square. So the T can be, we'll get as this value into the 3.12 whatever sensitivity we have. So this value, how much is that? Okay, it's coming something like 0.00129, something like that. So it will be like 0.00129 into 48241.81. It should come as how much? 9 into 48241.81. Okay, so 62.24 Newton meter. What was options were? Okay, so the unit here, see, it was in Newton centimeter, so we have to convert that into Newton centimeter. 62.24 into 100, that would be 62.24 I got. Wait, yeah, something like that. So 6224 Newton centimeter. So in the option we are getting 6240 Newton centimeter, right? I might have missed some like decimals here, that's why it is coming as 6224. So the answers are correct, 6240 Newton centimeter. Everyone got the answer right, or how to do that? Mr. Sharat, Mr. Nilgrib, Gitu, Divya Prasad, Srinath,
Yes, sir.
got right?
Yes, sir.
Ah, okay, fine. Okay, so we'll move to the next question. So the answer was D. Okay, next question is, during the subsurface investigations for the design of foundation, a standard penetration test was conducted at 4.5 meter below the ground surface. Okay, the record of number of blows is given below. Okay, assuming the soil at site as fine sand and water table at ground level, determine the corrected SPT value. N is SPT value here. Okay, N is the SPT value or standard penetration test value. Okay, so in standard penetration test, we know that what we do, we use the hammer or the monkey hammer, what we say, of some standard weight, and we give blow every time, and we note down the number of blows for the penetration of 150 millimeter. For each 150 millimeter of penetration, how much number of blows we are getting, we'll note that, and for 3 successive intervals, how much we are getting, that is total of 153 so 45 450 millimeter. Okay, so we'll go for this 450 millimeter of penetration, and then we'll see how much number of blows we have required for that much of penetration, and then we'll get the SPT value. Okay, so 3 times we'll do, that is N1, N2 and N3. N1 is for the first 150 millimeter penetration, whatever will number of blows we'll get, it will be N1. For second one it will be N2, and for third one it will be N3. Okay, now while calculating the SPT value, we only consider the second and the third penetrations number of blows. Why we are not considering the N1?
Because of disturbance, etc.
Yeah, so what we are
There
doing,
is some disturbance.
yeah, there can be in the first penetration, disturbance is there for every depth, But the thing is, there can be in the upper soil sample, if you say, we can have some impurities, plus we have the natural ground surface is there, right? Now if we go below that, we have some disturbances plus some impurities in the upper soil sample and all. For that reason we ignore this number of blows, and we call this as sitting count, just to understand the sitting and all. So we called it as sitting count. Okay, so we use some kind of samplers. If you have gone through, it is called split spoon samplers. Why it is called split spoon samplers is, it's like spoon, you will take the sample and then after taking it out you will split it. So that's why we are calling that as split spoon samplers. There are different kind of samplers other than the split spoon samplers, based on the mode of operation, what mode of operation you are going. There are several kind of this samplers. One is one drive samplers, then piston type samplers, rotatory samplers. A different kind of samplers are there. You might study in the upcoming lectures and all. Okay, so what we do is, we ignore this kind of sitting count, and then we go for this and as the SPT test. Okay, now again we have to do some corrections on this SPT test. What all corrections we have to do? We have to go for overburden pressure correction, and when we have the water table present, there will be pore water pressure also, right? So we have to go for dilatancy correction. Okay, so now in overburden pressure what we'll do, we'll correct the SPT value or the N value based on the some different research have given different kind of formulas and all. Based on that we'll go for the standard sorry, overburden pressure correction. So it's one of the formula is like N naught equals to N into 0.77 log of 2000 sigma naught, but sigma naught is the effective overburden pressure. This is the effective overburden pressure, and again I am repeating that it's like different researchers have given different formulas. Okay, overburden pressure in kilonewton per meter square. Okay, now once the overburden pressure correction is done, we go for the dilatancy correction. Okay, when let us say the soil, when it is in saturated condition, it will tend to dilate. Okay, so now after doing the overburden pressure correction, if the N0 value is greater than 15, we go for the dilatancy correction, and the corrected N, if we can write, it will be half of N0 minus 15 plus 15. Okay, when like whenever N0 is greater than 15 we are getting, we'll use this dilatancy correction, and then we'll get the proper SPT value. And this SPT test whenever we'll do, if let us say 50 blows we have done, and we are seeing that still 150 millimeter penetration has not been done, we'll stop the SPT test there itself. Or let us say if we are 100 blows are required for any 300 millimeter of penetration, there also we'll stop the SPT test. Or let us say if we are doing 10 consecutive blows, or 10 or 20 something, 10 consecutive blows or some number of blows, it is there in the IS 2131. Okay, so this SPT test is mentioned in IS 2131. The year I don't remember, 1960 or something. So in IS 2131 all the standard things are mentioned. Okay, so when we do this penetration test, why we do this penetration test, this kind of penetration test, this is one kind of penetration test, that is standard penetration. There are cone penetration test also. This penetration test, why we do, we with the penetration test we measure the resistance to penetration of a sampling spoon under dynamic or static loading. Okay, these tests are used very useful for general exploration of soil profiles, then strength, then other properties of soil. Okay, and now let us move to the question. What is the question? 4.5 meter mein the penetration test was conducted. The records is given like up to 7.5 centimeter, two number of blows are required. Up to 7.5 to 15, four blows are required. Then like this, these many number of blows are required. Question is what? Okay, determine the corrected N value and it is given that overburden correction factor is considered to be unity. Okay, so if we go for this formula, this is considered as 1. Okay, can anyone do this after corrections and all? Let me know what is the answer. We are assuming that the soil at site as fine sand and the water table is at ground level. Okay.
So value will be 16.5 because all burden correction is unity. Then 15 plus we take half of 18 minus 15. Last two values if we add it comes to 18 for 15
23.
centimeter benefit.
Okay. Someone says Gitu said 23, right? Okay, let me write. Gitu said 23 and Mr. Shatish said 16. Mr. Satish, did you say 16, right?
16.5.
16.5. Okay, let's see. Okay. Anyone else? Anyone? Sarat, Najrul, anyone? Nazrul or Najrul? I don't know how to pronounce. Mr. Nilgrave?
Trying, sir.
Okay. Okay, see, if you want the options, I can give. Sorry. Oh, I have written there. Sorry. Okay, so options I will write again. Options are A26, B23, C20, and D31. Mr. Satish, can you please check once because 16.5 is not in the option.
Twenty-three is the correct answer.
Okay. If anyone else is getting anything, let me know. Okay, I will do now. Anyone got any answer? Okay, I will do, let me do now. Okay, so what was there? It was mentioned like at this number of depths we have these blows. So what I said, the in the SPT test we remove, we don't consider the setting count. Setting count is in the number of blows which we are getting for first 150 millimeter. So first 150 millimeter means up to this, up to 15 centimeter will not consider this. So the number of first, this 2 and 4 will not consider. This is N2 and this is N3. Okay, yeah. So n is how much then? N will be equals to how much? 7 plus 6 plus 8 and plus 10. Okay, 7 चौक 13 8 21 8 10 31 31. We are getting n as 31. Now what we have to do, we have to go for the overburden pressure correction and the die latency correction. And it was mentioned that overburden pressure correction was unity, right? Overburden pressure correction equals 1. So n0 will be equals to 1 into n, that is 31. And then we have to go for die latency correction, because what we have seen in the question, see, it is mentioned that water table is at the ground level, so this means the whole soil is saturated, so we have to go for die latency correction also. And again here what we are seeing, n0 is 31, that is greater than 15, right, as we have seen. So now if n0 is greater than 15, that is 31, so what we'll do, we'll use the formula for die latency correction, that was half of n naught minus 15 plus 15, that is half of 31 minus 15 plus 15, 15 15 16 16 8 8 plus 15, that is 23. So the correct answer is 23. Okay, any doubt?
No, sir.
Clear, right?
Yes, sir.
Okay. Okay, we'll move to the next question. So the correct answer is B. Next one is, which of the following statement is not true regarding the interpretation of standard penetration test results? So your options are, the number of blows obtained for the first 15 centimeter depth is not considered in the determination of SPT value. Question is, which of the following statement is not true regarding SPT test results? The first option is, the number of blows obtained for the first 15 centimeter depth is not considered in the determination of the SPT value. Second one is, the measured SPT value for fine saturated sand will always be higher than actual SPT value. Okay, the measured SPT value for fine saturated sand will always be lesser than the actual SPT value. And last one is, die latency correction is required for saturated silt and fine sand. What you guys think, what will be the correct answer?
C is the answer.
The measured SPT value for fine saturated sand will always be lesser than actual SPT value. Okay, anyone else? Is C correct option, or do you have any other thing in your mind? Anyone else? Do you agree with C or any other option? See, the first option, that is, the number of blows obtained for the first 15 centimeter depth is not considered in the determination of SPT value. In the last problem only we have seen, we are not considering the sitting count. That is, the first 150 millimeter penetration, whatever is there, or that whatever number of blows is there, we are ignoring that because it is considered as sitting count. So the first option is true for the SPT penetration test. So that is not the option. Last one, that is high latency correction is required for saturated silt and fine sand. If it is saturated silt and fine sand, then obviously we have to go for high latency correction. So the option B and C are the measured SPT value for fine saturated sand will always be either higher or lesser than the actual SPT value. Mr. Satish said that it will be lesser than the actual SPT value. And why so? See, that is the correct answer. And why so?
Because pore water offers resistance.
Hmm.
Because of that, value is inflated.
Yeah,
So
yeah, correct.
we have to bring it down.
Yeah. So if our soil is saturated, then what will happen? We have to we have the pore water pressure. Okay, and that will give some resistance, and that will have uh, some effect on the SPT value. Now for that, what we do? We do the dye latency test correction, and from there, if we get the n value and the n corrected value, what we see, the n corrected value will always be less than that of the actual SPT value. So the correct answer will be actual C, that is the measured SPT value for fine saturated sand will always be lesser than the actual SPT value. Okay, so C is the correct answer. Clear? Why the measured SPT value for fine saturated sand will always be lesser than the actual SPT value? In the last problem also, if you can see now, see see the n that we have got, where is that? Okay, we have done there. N we have got was 31, and after doing the dilatancy correction we are getting 23. So what is happening, the actual SPT that we have got from the SPT test was 31, but after doing the dilatancy correction, as the soil was saturated, what we have seen, the measured SPT test, that is sorry, value, that is 23, is less than that of actual SPT. Okay, so the answer will be C. Okay, next question. The range of SPT values for soils of dense consistency is, well, this is simply you have to remember and all. The range of SPT values for soils of dense consistency is how much? Anyone? It's like you have to see that if you're not remembering that, it's fine. Anyone?
Greater than 50 is normally rock.
Yeah, so it is very dense.
It's
Fine.
greater
So
than
30
50.
to 50.
So for dense consistency, it is like 30 to 50. Okay, if SPT value is from 0 to 4, it is considered as very loose. Okay, and if it is 4 to 10, then we are considering it as loose. If it is from 10 to 30, we are considering as medium dense, and if it is 30 to 50, we consider it as dense, and if it is greater than 50, we consider it is very dense. So the answer for this will be B, that is 30 to 50. Next question is, dilatancy correction to the field measurement SPT value is required for what type of soils? Okay, dilatancy correction.
Saturated sand, yeah, silt. Option B.
Why not saturated clay and silt? The answer is correct, but why not saturated clay?
Um,
Basically, this test gives erroneous values for clay soil, etc. For sands, etc., it's a good test.
Yeah,
So
okay.
in clay, there will be a lot of disturbance. So aberrations will be there. So correction is specified only for very, very fine soils.
But clay is a
It is
very fine
prescribed,
soil.
but sticky. It is very sticky type.
Okay,
So this
the
correction is basically for pore water. Pore
yeah,
water
this is what I
resistance
want.
does not
Uh-huh.
come in picture.
Okay, yeah. So in clay, the voids are very less. So the pore water pressure that will be there will be very less, and for that we don't have to go for dilatancy correction. So for that reason, the answer for the, like, for what type of soil we'll use for the dilatancy correction to the field measured SPT will be saturated sand and silt. I hope that after this there is no. Okay, this is what SPT. Sorry, STP test is there. That's it for today, I guess. Yeah. Okay, so this all will be, I will be sharing again. If you have any again, if you want to see and all, you can go and check. Any other doubt for today's session, or any in week 2 lectures? Anyone? Once I will check all are present, because I have to give that. 1 2 3 4 5 6 7. Okay. Any other doubt?
Sir, what? Sorry, sir. Why, sir? What is the other usage of SPT other than finding the denseness of the soil?
uh,
Is there any other usage, or is there any limitation?
See, other than knowing the density, we also go for strength. Okay, like for sand, marginally disturbed samples can be collected. Again, for the clay, if you say clay also we go for, but we don't do the tile density correction. Why? That I have said, right. This SPT test is give the approximation, approximate soil strength, that how much soil strength will be there and all. But let us say in more realistic values on strength and compressibility characteristic it will give. Okay, as see, we are going for SPT test. Obviously, there will be undisturbed sampling, and if we use that samples in the laboratory and all, we can go for this strength compressibility for clay soils. Okay, again, let us say you are doing the SPT test for weather rocks. Weather rock means the rocks which are being getting weathering process. Okay, now in case of the highly weathered rocks or weak rocks, SPT will reach refusal. Like as I said, that in the IS 2131 it is mentioned, like if the blow is greater than 50, or for less than 450 millimeter penetration, we'll stop that SPT there only. Okay, so other than the density, we can understand the this strength. For clay soil, we can go for compressibility also, compressibility characteristics. Okay, so anything other than that, yeah, like this only: density, strength, compressibility for clay and all.
Okay, sir. Thank you.
Anything other than this?
No, sir. Thank you.
Okay, do I have any other question? Let me see. Strength test. Okay, what are the properties of solid computer? Soil that can be determined by SPT. Okay, other than the relative density of cohesionless soil and the compressive strength of the cohesive soil, it is also used for the angle of internal friction of cohesionless soil. Okay. Okay, so if all doubts are clear, what was the ninth question? Okay, let me see what was the ninth question. So I'll not say what is the problem, but I will, let me see if I can say something. To question.
There is one more question, sir.
Yeah.
Sir, can we go directly for SPT test? Because in SPT test we are also collecting the sample.
Hmm.
Then why we go for different type of boring? Like
Because SPT test will be expensive than other borings. So it is based on project to project. Okay, if it is bigger structures, if you are going to do, you have to people go for SPT, then cone penetration test and all. Okay, if it is smaller kind of projects, we'll use this boring, drilling and all. Because as you said, we'll have some kind of some will have high end this machines, and some will have low end machines that can affect the accuracy of what we have observed. So based on the projects, based on the site, based on several other factors, we go for these tests. Okay.
Okay.
Okay. The ninth question was a vein sheet is the torque required to shear the soil sample is this much. The vein is inserted to a depth of inside this. Okay. And this is like we have done one vein shear test problem. No, I think you can do that. Okay. Okay. Anything other question or any other doubts? If it's not there, we'll meet next Monday, same time, same link. Okay.
Okay, sir.
Okay, well presented.
Thank you.
Thank you, sir.
Okay. Thank you. Thank you. You guys can
Thank
leave.
you, sir.
Yeah, you guys can leave. Thank you.
Okay, sir. Thank you.
Okay. Thank you.